My name's Alex. I'm a pre-sales engineer at Redgate, and that means it's my job to make the stuff work. So I've spent the last 5 years going into company after company after company, helping them make their database delivery fly. Now, inevitably, to do that quickly and easily, we're going to use a tool to do it rather than build the whole infrastructure ourselves, because when we build the whole infrastructure ourselves, you have to support it yourself. And normally there'll be somebody that built it that's a button on the bottom. Fantastic. So there are a whole bunch of tools that are available, and there are some examples up here. I was going to include TFS as an example, but then yesterday in the afternoon at some point I was faced with the prospect of installing TFS. So instead you've got some other options to choose from. Now, one of the things I'm going to talk about quite a lot today, there are basically two classes of solutions to setting up a really nice automated process for delivering database changes. You've got the migrations class of solutions, where you have some baseline of your database state and then upgrade script after upgrade script, and you gradually append all of these, and then you can just run them all to upgrade, and possibly you'll have downgrade scripts to go back down again if you want to. So that's what options 3 and 4 are. There are a couple of migrations-based solutions. You also have state or declarative-based solutions where you just define how the database should look at each point in time. And then the theory is you can have more repeatability and, oh, the word's gone from my head now, where it all looks the same in every single environment. That's the word I'm looking for, across the different environments. And so the options 1 and 2, state-based solutions. Now, there are pros and cons both ways, and that's something I'm going to talk about today. I'm not going to stand here and say either migrations or declarative is universally the best, and the other one is the scum of the earth, which a lot of people do. So to start with, I'm going to ask you to choose which is your favorite set of tooling. I need you to choose either option 1 or 2 for a state-based model, and either option 3 or 4 for the migrations-based model, and they're the two demos that we'll use today. A little bit of background, SSDT, that's basically Microsoft. All of this is based on SQL Server, by the way, because that's where my experience is. So SSDT is the Microsoft Visual Studio Database projects. The Redgate is a company I work for, but I'm not here to sell my tools, so you don't have to pick it. Bamboo is a release management and continuous integration tool by Atlassian. TeamCity is a CI server by JetBrains, and Octopus Deploy is a release management tool. ReadyRoll is a commercial project type for setting up migrations-based deployments. So they've tried to put a lot of work into having quite a sophisticated solution to solve some of the problems with that process. DBAs is an open source, very, very, very simple tool, which is easy to use, easy to set up, and has all of the problems that come with migrations solutions. The idea there is that they're very, very simple and very small. And then TeamCity and Octopus again, and then you've got Jenkins, which is an open source CI server, which probably most of you have used. So option 4 is very much your open source stack. So who wants between 1 and 2, who wants option 1? And who wants option 2? Oh, that's a bit even. Is somebody else going to call that for me? Okay, let's do it by cheering, because let's see if who wants option 1? Who wants option 2? Okay, all right, 1. And between 3 and 4? Who wants 3? A handful, and who wants 4? A bigger handful. Okay. So we're going to go for option 1 and option 4. While I just take a couple of seconds to set that up, here's a picture of an elephant in a room. So I'm going to, I can kill TeamCity. Don't want you. Don't want you. Do want you. Do want you. I will keep you. Good to go. Right, where's my flicker gone? Right, so as I said, this is normally a talk that's an hour long, and the first half of it is about why you should do continuous delivery. but I kind of think I'm preaching to the choir there. So I'm going to take slides that I normally spend 5 minutes talking about, and I'm going to try and do one line for each slide. Who's read a software book in the last 20 years? Did it have some of those words? Good, we've worked out that's good stuff. On the other hand, on the other side of the coin, you've got DBAs and stuff. People who look at DBAs in the room as opposed to developers in the room. So DBAs in the room, you care about this stuff. You care about looking after the production database, because you know what? Looking after the production database that's got all of my business information in it, that's more important than that little tiny incremental release. So it's more important that that doesn't go down. So we do need to take care of that stuff, and this is particularly important in the database. So much so, and this gets so divisive, the whole DevOps thing, yeah, with databases it's a big thing. You've got people on the dev side and you've got people at the ops side, and they tend to get ratty with each other when people on either side do stuff that upsets the other, especially when this happens. And the DBAs tend to be the first people to find out about it, and they call the developers and they say that. You've heard that before then. And a lot of the time it's the developer's fault, because the developers do stupid stuff that works on their machine when they've only got a few lines of data. But when it runs on production, it doesn't work so well. But sometimes it's the ops guys that are the cause of the problem, because you know what? While the ops guys are really good at managing performance and monitoring stuff, sometimes they're going to go and make that hotfix directly on production because they're not developers, and they're not as close to stuff like source control and continuous integration and managed processes there, which means that when we deploy, we're not taking into account that hotfix. So sometimes this communication problem is because developers are doing stupid stuff, and sometimes it's because of ops people not really understanding the process properly or not working with developers. And this is mainly because these two different groups of people have got completely different objectives. I'm not doing very well at one sentence per slide, but I'm going as quick as I can. So the solution I'm going to suggest is to start thinking about pipelines, to start thinking about optimizing the whole, to get everybody working together, and to really focus on what the actual bottlenecks are. And the reason for this talk is because I'm going to propose to you that the database, for a lot of you, is the bottleneck, especially if you have to deal with legacy relational databases. That's the stuff that you don't want to release that every other day or every 5 minutes, because actually you're more comfortable releasing that once every 6 months, because it's just painful when you do a release. And there are a bunch of reasons why it's hard. First of all, they're messed up, crazy languages that nobody understands, even if they think they do. Developers will try using an ORM tool or something, and that's actually a strategy of building databases that I'm not going to talk about here, because I've only got half an hour, so give me a chance. I've done 4 demos for you. SQL is a messed up, crazy language. It's about the only language I know that the guy who deploys it understands it better than the guy that wrote it a lot of the time. I can't imagine the average sysadmin cracking open the C# project and telling the developer why they did it wrong. But when you give a DBA a deployment script, they tend to come back at you and say, have you thought about this? Also, developers will try and do whatever they can to stop writing SQL using an ORM tool or something, because they can live in their C# world. But I have mixed opinions about that. A lot of people say it's the future, it's the way we're moving forward. I think it's about feedback loops, and you don't get that feedback about that stupid code that you wrote, which is why DBAs think that the ORMs create credit code that runs slowly. It's because the developers don't get that feedback. They don't see it because they're running it from the C#. I don't know. You also have the persistence thing. Apparently, we don't want to delete the data when we deploy to production. Apparently, that should live on. Apparently, it's a problem when we do that, so we need to think about our mechanism for... It's not as simple as just replacing the previous code with the new code. We need to think about how we get from state A to state B, which adds a whole other level of complexity to what we need to think about. I mean that in a good way. DBAs are supposed to be paranoid. It's what they're paid for. If I had a database with all of the current accounts for all of my customers and I'm a big multinational bank, I'd want the DBA to look after that, because I don't want to lose that data. And the DBA is a person that gets woken up at 2 o'clock in the morning, has to fix a problem, even when it's a developer's fault, and then they have to be back in the work at 9 o'clock the following morning. So I think they've kind of got a point to be paranoid. The problem that you need to look out for here is when that isolates the DBA, and then you get the whole dev versus ops thing happening, and developers moving around the DBA because they're going too slowly, and the DBA just locking everything down because they don't trust the developers, because the developers go around the DBA, or the developers do stupid stuff. And so what I would say is that DBA paranoia is something to be cherished and loved, and they're paranoid for good reason, because they've been burned by this stuff before in the past. And you know what? If you want to start thinking about the sorts of tests that you should start automating, starting by thinking about the reasons why DBAs are paranoid and what they're paranoid about is probably a really good place to start. But in general, the solution to a lot of these problems that I'm going to suggest to you is continuous delivery, and specifically by that I mean these three pillars. First of all, we need to have our databases in source control. Does anybody here have a database? Put your hands down if it's in source control. Okay, good. Start by putting your databases in source control, because any sort of continuous delivery change management process starts with making sure you know what the changes are, that you can control them, that you can say what the database looked like on the 25th of January 2015, that when somebody comes and says there's a problem with my database, and you say, well, which version are you on? You know what that means. The next thing we want to start doing is start thinking about continuous integration. Now, this is a term that's a bit overloaded, but basically what I think it means is having all of that source code in a central location, having what we call a source of truth, which should be source control, and every time we make a change to it, we're going to be carrying out some sort of verification, some sort of test on it. Now, the most obvious first place to start is by building that database. Does that code in source control, which isn't actually a database, it's scripts of .sql files or something similar, can I turn that into a database? And then I want to start thinking about the other sorts of tests I can do on that. Now, in today's half-an-hour talk, where I'm trying to cover all sorts of different ways of achieving this, I'm not going to get as far as unit testing the database. It's something we should be doing. I'm not going to talk about it today, but that would fit in continuous integration as well. And finally, I want to start thinking about automated deployment. Once I've tested that code in source control, I've had some sort of verification of it, I need to know that I can put that into the production environment in that state. What I put in production needs to exactly match. I need to have that consistency across my environments. Because if I put my code in dev, I deploy it to test somehow, I see a mistake, I fix it in flight, I put it in production, then DBA fixes a hotfix on it, adds an index or something because that doesn't count as a change, then the thing in production doesn't match anything that I've worked with in dev or my test environments, so I've invalidated a good chunk of my testing. So I want to make sure I've got that consistency between environments. So that's the goal that we're heading for. Now, there are a couple of different ways of doing it. And I've included a couple of pictures in my deck now, and I'm a little bit ashamed of including this one. Possibly some of the ladies in the audience are going to enjoy it, but I didn't enjoy looking at that. There tend to be more than one way of solving any problem. And anybody that tells you that there's only one way to do this, this is the right way, and everybody else is doing it the wrong way, it's probably either wrong or they're trying to sell you something. There are a couple of different ways of doing this. There's probably more than two, but most of the solutions I've seen fit into one of two main categories. And people do tend to think that one solution or the other is the correct way of doing things. You've got people sitting in the migrations camp, which I described earlier, saying that anybody that does state is completely wrong, it's never going to work in production. And you've got people that that promote the state-based solution, saying, I used to work in the bad old days of managing all of these scripts and trying to get the ordering right and trying to make sure that when you made a change and I made a change, we combined it in the right way. People say that that's bad too. What I'm going to propose is that actually it's more subtle than that. For some projects, one is a better solution. For other projects, another is a better solution. For some people, one is a better solution. For other people, another is a better solution. I'm going to try and avoid trying to ram down anybody's throats. One way is universally the better way of working. Just to try and put into context, the migration space, with databases, you've got the state, you've got the transition, and then you've got the next state. In a migration-based solution, we're mainly looking at the transition. We're mainly looking at how you get from state A to state B. And the state-based, we're looking at the opposite, and the actual state at either end. As I said, people get really angry about this, and you have people on both sides saying so. So, for example, Paul Stovell, he's the guy that wrote Octopus Deploy, and I'm sorry for the lines on this screen, so you might not be able to read that very clearly, but what he's basically saying is there's no more reliable way to deploy to production than a script that I have run, and I've run exactly the same script on every single one of my environments, which is fantastic until somebody makes a change directly to the production environment, and then none of your versions look like what they should look like. Equally, you've got... this is Gert Drapers. He is the guy who initially built DataDude, which became Database Projects, which was the forerunner to SSDT and all of that stuff in Microsoft. And he's saying that when you try and do those upgrade scripts, it just gets far, far too complicated for a bunch of different reasons. I've got someone over there thinking that one way is the right way and one way is the wrong way. Especially when imagine you've got a database that supports many different development teams, and they're all building on it for different reasons, for different projects. When they're all putting in their scripts, if you get a conflict between two different scripts, if you get the ordering wrong, an upgrade script is generally only considered really reliable when you know the exact start state and the exact end state. And if you don't, then you potentially have problems. And if you've got another team that's making changes as well, then when you try and add your upgrade script to it, then you can have complex dependency issues going on. So just to briefly outline the reasons why I think a migrations-based solution is good or bad, it's simple to understand. It's easy, right? You can understand what's happening there. This is the upgrade script, that is the upgrade script. It feels much more in line with the fact that databases have state, and you have to worry about that persistence. It gives you a lot of control over how you're going to apply that upgrade. So if you've got data migrations or something going along, you can have complete control over that. And with that control comes responsibility, because you can write bad code, and that can have dramatically bad effects. It's also free, because it's quite easy to write yourself, or there are a bunch of open source tools out there that can do it for you, which is great. As I said, problems when you've got distributed teams are going to have a very strict process. Also working out the differences between version X and version Y. If you want to know exactly how a database has changed between version 17 and version 243, you've got a lot of lines of code to read through. And I mean, you can do a test by generating the previous version, then generating the latest version, then using a diff tool to work out what the differences are, but it's not the same as kind of understanding how the database has changed at each point in time. And with drift, by drift I mean when somebody changes the production database, that drift persists. You never get rid of that. Somebody could change the production database and you would not pick up that there's a problem. You wouldn't see that because you'll just keep appending your scripts to it, CMAT. Whereas with a state-based solution, and by the way, you've got to get Lego into a talk about continuous delivery, right? I think that's like an unwritten rule. And also I thought Stormtroopers, they're all clones as well, so you've got the whole consistency thing going on. So I had a little think about a good picture for this. It tends to be an easier workflow. It tends to be you're treating your database more as code, which means that natively tools like source control systems and stuff tend to work, tend to make a bit more sense. Scales better with larger teams in the same way, because you're no longer restricting yourself to exactly how the upgrade occurs. You can say how you want it to look, and then branching and merging and everything begins to make a lot more sense. And you've got that consistency. Whenever you deploy version 17, you know exactly what version 17 looks like. You can test version 17. Version 17 will always look exactly the same way. It does mean you need to worry about how you get from state A to state B. It does mean that you're probably going to be relying on tools to sort you out, or you're going to be scripting it out yourself. Now, we don't like scripting it out ourselves because that's a manual process where errors occur. It is kind of what you're doing by default in the migrations-based approach. But in this approach, it tends to be an afterthought, which isn't ideal at deployment time. And in this scenario, drift is a problem because you're always going to blast drift away. If you're going to do a diff between the version you want to deploy and whatever's on production, then you're going to end up blasting that version away if you're not careful, if you've not got a good review process. So that's all I've got to say about it. I'm now going to start showing you a couple of different solutions. So the first solution I'm going to show you, I'll start with the migrations one, shall I? Now, if I put this here, I hope that's going to not die. So DBUp is a cool tool. Let me just, what have I got running here? Let's file, oh no, open. So DBUp is a really simple tool. There's a bit of sample code that you use to create a very simple project. This is basically just copied and pasted off the front page of the website. Oh, using Visual Studio on a small screen is horrible. You have in the Solution Explorer, literally you have the scripts folder and a bunch of different scripts that you can add to it. So I'm going to add a script, new item, I can't find out a way of just adding a SQL script. I've obviously got an old version or something, so I'm just going to go for a text file. I'm going to call it 02, is that the right? I've got script 02 adding a sproc .sql, and you've got to add this as a embedded resource. And now I can write a script. I can write whatever SQL script I want. So I'm going to go. I'm going to use IntelliSense to just write a very simple store procedure. I'm not going to try and do anything particularly clever at this point because I'll mess it up because I'm not a developer, I'm a pre-sales engineer. And I'm going to save that. And now the first thing I said is I need to put this stuff in source control. Well, this is a Visual Studio project. I can source control it as easily as I can source control anything else. Just for everything on this machine, I'm just using Git with Visual Studio because that just seems to be the simplest way of doing it. So I'm going to go to source control, I'm going to go to commit, and this is brilliant. I can commit my code into source control very easily. I'm going to write adding a sproc. Actually, before I do, first of all, I'm just going to show you that this actually works. I've got a DBAs dev environment, which has a couple of tables I created earlier, and no stored procedures yet. So what I'm going to do in Visual Studio is I'm going to just run a debug build. And this is going to execute any scripts on the dev database that haven't yet been executed. So this is telling me it's been successful. Can everybody see or at least vaguely enough to see what's going on? So if I go back into Management Studio and refresh my stored procedures, we'll see now that I do have my get1 stored procedure. Now I've got an integration environment over here, and this is going to be populated as part of my continuous integration build. So what my continuous integration build is going to do is going to build the database. So the very first thing it's going to do is it's going to take that code, make sure that it can correctly populate the integration database. And as I say, I would at this point ideally go on and write more tests and unit tests for any business logic in your stored procedures or whatever you've got there. But right now I'm not. I'm just going to commit that into source control. And I've got a Jenkins build over here. Which is set to refresh every 13 seconds. There we are, you can see it's running now. And it's finished now, didn't take very long to build. If I take a quick look at, taking a look at the build log is going to be horrible on this screen, so I'm not going to bother. But if I go back into Management Studio now and refresh the integration environment, refresh, there we are, there's my get1 stored procedure. So that happened automatically off a source control commit. It's automatically validated that that code can work to build the database like that. And finally, if I want to deploy to production, we all like one-click deployments, right? So in terms of reviewing and who's allowed to do this, it's easy to review the code. It's in source control. Script, 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 script. Easy. You know that what every script has run exactly in this state on previous environments because that's the only way that you're able to deploy to your integration environment. Or any other environments that you have up the pipeline. You can review the source code to see what the script is going to be, so if you're happy with it, one click. And let me just, there you are, that's scheduled the deployment. Oh, I should have shown you beforehand that it wasn't there. It's now going to be there. I'm going to ruin the final moment of this demo. But stored procedures, there's a get one stored procedure. So that's continuous delivery for a database with open source tooling in terms of putting your code in source control, validating that it works okay, and deploying it to some production environment. We've got proper source control underway, so we know what the changes are. We can review that properly, and it wasn't too onerous. Having said that, this is an ideal way to, if you've got like a little embedded database in some product that you deploy to customers that you know never changes, this is ideal. If you've got a database where people are going to be changing it, perhaps rather too many people have access to it. Who's here has worked on a project who here has never worked on a project where somebody that you didn't want to have access to the production database has had access to the production database? Yeah, okay. Has anybody ever had somebody change the production database that shouldn't have? Yeah. So in that scenario, this could be a problem because it's not going to pick up that that change has happened. The only logic to work out what script is going to be run, you've got this table here which has got schema versions, and if I just select all of the information on here, you can just see very simply when Management Studio stops being slow, you'll be able to see just a detail of every script that's been run on it so far. So when I run the little executable, it just applies any additional upgrade scripts to it that haven't yet been run. So anything that happens outside of this process becomes a problem. So yeah, there are reasons why people have concerns about this approach, but on the other hand, dead simple, dead easy, and it works really nicely. So let's look at the other option. So Visual Studio, SSDT, file, open project, SSDT. How am I doing for time, by the way? Have I gone wildly over already? 1 minute. Brilliant. Brilliant. Here we go. Okay. Oh, okay. Well, I was going to take the challenge. So I have here. This is everybody. Are most people here familiar with Visual Studio Database Projects, SSDT? Okay. So Visual Studio Database Projects is basically a way or a Visual Studio project that contains all of the schema that represents the state of your database at this given point in time. So for example, I have a get bars stored procedure, which selects star from bars. I have a get foos stored procedure, which grabs everything from foos. I have a bars table. I have a baz table, which Visual Studio is being slow about for the time being. What I'm going to do is I'm going to go right click, add table, and I'm going to call it foobars, add, go away. Visual Studio with no screen space is horrible. So let's add some columns. Let's have a foo. Yeah, you can be an nchar. Let's have a bar. Oh, where am I? Let's have a bar. Let's make you an int. Yeah, that'll do. Good, I've got a table. Now I'm going to save that. You can see foobars has existed down here. This is my new table. It exists in my solution down here. I'm defining how the database looks at this point in time. I can right-click on the project. I can commit it to source control just like I did before, so I can begin to keep track of the changes in source control. I can revert back to any revision whenever I want. I just need to write a comment. Added foobar table. Commit this to source control. Yep. And now I've got Bamboo up and running here. Bamboo is a continuous integration and release management tool. So if I come back to the dashboard or build plans, you can see I have a build plan here. It's currently running. If I take a little look at what's happening in the build, I won't go into the details. There is a bunch of tooling that allows you to do this. Redgate has got tooling. Visual Studio's got tooling. What it's doing is it's going to package up this Visual Studio database project, in this case into a NuGet package. It's going to build the database on a temporary database and then chuck it away to make sure that this package can be built in its current state. We then have a process to, once the build has completed, once a build is completed, we've got a process to take this database, this package, and deploy it to another environment. And how that works, in this case I'm using the Redgate tooling because it's what I'm familiar with, but you can use SSDT tooling to do similar stuff based on DAP packs rather than NuGet packages, to look at the difference between my database and another database over there, generate me a script. For my integration environment, I'm just going to deploy it straight away because I don't want to have someone come along and approve every single database deployment to an integration environment. But then we can use the same approach to deploy out to a production environment when we want to, and at that point we can introduce kind of a break point and a review point where we can review the changes before they go live. We can review the script before it goes live. One of the really nice things I like about Bamboo as a CI server release management tool is, while it is not the best CI server out there and it is not the best release management tool, this screen here is nice. You can see information about the build on the left-hand side, and just on the right-hand side you can see where it's been deployed to, which is quite nice. A lot of tools don't have that. You can see that we're currently in the process of deploying to integration on an automatic basis. Automation rocks. And in a few moments' time I'll be able to deploy that to production with one button. Since that's in process and I don't want to overrun, although I'm not quite sure if I already have, 5 minutes, good, okay. If I've got 5 minutes we can wait. How are we getting on? I thought I was going to go to the logs at that point. Still going.
And this is the low detail version of the tool.
Pardon?
And this is the bit of the tool that's low on detail, you're saying?
Yes. Is it high on detail? Possibly. I'm possibly trying to, by not going into too much detail, I'm possibly skipping over some important points. I apologize if that's true. There we are. That has deployed to the integration environment. It's made my change. It's deployed it to my integration environment. And then to deploy to production, I can simply go to the production environment and click deploy, I think. Can't remember where the deployment button is. This is me being a jack of all CI servers and a master of none. Oh, is it because I'm not logged in? Gotta remember now. I think that. What was that? And now I can just press the button to deploy. I was wondering where the deployment button had gone. Start deployment. Yes, start deployment, please. And that's going to deploy to the production environment. I'm not going to hang around here and wait for it, though, because it's a bit boring watching logs go through. So what I am going to do is I'm going to go back to my slides. When I was about 10, I played the violin, and I was absolutely terrible at it. Never, ever, ever give a violin to a child. Give them a guitar. You can make a lot of money off playing guitar badly. You can make a lot of people very upset by playing violin badly. My violin teacher asked me how long I practiced for, and I said I practiced until I got it right, which is the wrong answer. Anybody that's ever given that answer is wrong. Any Olympic athlete will tell you get it right, and then you start practicing because it's that muscle memory. That's why you actually get good at stuff. If you've been practicing until you get something right, then you've been practicing doing it wrong all the time until the one time you got it right and then you stopped. And you've not built up the muscle memory to do it the right way. That's why I was never a very good violinist and why I became a bad guitar player while I was a teenager instead. Same is true of your deployments. We should be deploying frequently. We should be automating the processes we can. It should become a boring, easy thing. I'm preaching to the choir again. But we ignore that we ignore that guidance for our database. So many of us have horrible, gnarly database deployments. And granted, I've been using Mickey Mouse projects here rather than actual real legacy complicated systems, but that's more than a half-hour talk. But we should be trying to think about the ways that we can work better between dev and ops. And one example is a project I worked on a little while ago. These are a bunch of people from Farm Credit Services America. You can't see it on the back, but there's like a perfect description of a continuous delivery approach that everybody should follow. But the production DBA basically said, hey, we use at this point it is Redgate because that's what I did on the project, but you can do it, other tools are available. But production DBA said, hey, we've got an issue where he's a production DBA for about 12 different development teams who are all touching the same databases. They're all using different source control systems or no source control systems. They hand him a script, expect him to run it in a couple of hours, and he looks at it and says, well, I'm not running this, and then there's a fisticuffs. And so what he decided to do is he called in Redgate, he called in me and one of my colleagues, and we went over and then we talked to them about how they could improve things. What we're able to do is get the chief architect and also the head of the database and .NET development teams all into a room and thrash this stuff out. And as I was mentioning before, as much as I can go on about the technical solutions, it's only really going to work when you get the people working together. Exactly like, where was he? The guy that did the talk beforehand, when he had, exactly like Chris said, when he had the dev and the ops working together. This is exactly the sort of thing that is going to actually make this work when you've got the DBAs and the developers working together in a room, and hashtag DevOps happens. I've been Alex Yates. I work at Redgate. If you want to talk to me about building databases, I'll be around for a beer, and I'm sure we're going to go to a pub or something afterwards. And if you want to see the full version of any of the demos, come badger me, and I'll tell you all the kind of hidden secrets in the demos about what actually wasn't working, but I didn't want to say it at the time. That's where my images came from. Thank you. Oh, I should say any questions. Yeah.
I just want to clarify there. Essentially, all the tools you talked about, there's two key ethos essentially.
Yeah.
One is state, and one is migration based.
Yeah.
But both have the same deficiency, which is distributed teams.
Yeah.
Do you know if there's any idea?
So, distributed teams have you ever worked in a distributed environment? And how did you solve that? Get distributed source control systems?
We basically had to inspect migrations as they have. We use the migration approach, and as things touched on the same objects or changes happened in multiple services we're touching, we would just have to spot it happened.
So
we didn't have a real solution.
So what I would say there is, when you're working in a migrations-based approach, every time something gets overwritten, you need to think about how to handle that migration script. So you end up repeating work a lot of the time to work out how to get from state A to state B. If you work in distributed teams in a state-based model, that just becomes a regular merge conflict in whatever source control system you're using. You can treat it exactly like code. And it's only later, when it comes to actually the time that you deploy, that you need to worry about how that script, how the changes occur. And there are diff tools that can help with that by many different companies, some of them free. Or at that point, when you actually know what it is you want to deploy and what state you want to get from and what state you want to get to, you can think about how to write that migration script once.
Well, we did a lot of that. It's more to do with when two migrations come in that conflict, but it's not a difficult, obvious way to catch it, other than having both diffs inspected over time. You might get 10, 20 diffs a day. Okay, that's maybe extreme for data. But,
well, it depends on projects. Database
maybe 5 or so, but you might miss the fact that two of them change the same table. It might conflict, or not even conflict, just that one might break one service, not the other.
So
might touch the same fields even.
Managing conflicts when you're working in a state-based model is exactly the same as managing conflicts in your application code. And then the problem about how to deploy it comes later. So databases don't add any specific, when you're in a state-based model, databases don't add any additional problems to what you already have to deal with. When you're in a migration-based model, they do, because every single time it happens, you need to work out how to do the migration script again.
Any more questions? Okay, thanks again, Alex.
No worries.